everyone. I'm Mike DeVerde. I'm an aerospace engineer. Welcome to another edition of Robots in Space. Today I'm wearing my Delta II rocket shirt. First, let's locate the Curiosity rover on a false color topographic map of the entire surface of Mars. Look at the large black arrow pointing to the location of Gale Crater. This is where the Curiosity rover landed on Earth date August 6, 2012, which was Sol 1 on Mars for Curiosity. Now you see a close-up of the entire circumference of Gale Crater. The large black arrow now points to the elliptical landing site of Curiosity rover within Gale Crater. The landing site is on the crater floor, which is named Aeolus Palus. The center of Gale Crater is either called Aeolus Mons or Mount Sharp, which rises 18,000 feet above the crater floor. On the right, there is a map of the entire traverse of Curiosity since landing in 2012. Here's a selfie that Curiosity took on Sol 1126. This is a panorama video that was created using many individual photographs that were taken by Curiosity once it had ascended to a local ridge of Mount Sharp inside Gale Crater. The view is to the north, looking at the mile-high rim. Locations of the path that Curiosity took since landing in 2012 to the time of this panorama in 2018 are now indicated. This panorama gives an idea of the landscape that this rover has traversed in the first 6 years of its 12 years of travel. Locations of the path that Curiosity. Now we will fast forward to the current location of Curiosity for an update. Curiosity is roaming Gale Crater, shown on the map of Mars, near the equator in the east. This is a photo from the mass cam on Curiosity on Sol 4338. On Earth, that's October 19th, 2024. The terrain has lots of rocks, which ultimately prevented an autonav. Here, because of the many large rocks in the terrain, there was a concern that auto navigation would fail, which could position Curiosity in a bad orientation for the next communications window. The drive reached about 90 feet, whereas an autonav in better terrain might have been much longer, like about 160 feet. After the drive, we did a mass cam survey to observe soils along the traverse path. This image from Perseverance's right nav cam looks back along rover tracks from Jezero Crater. This image was acquired on October 4th, 2024, which is Perseverance's Sol 1288, at the local solar time of around 1 in the afternoon. Perseverance just keeps marching up the Jezero Crater rim. This steep ascent through the Martian regolith can prove to be slow driving for the rover, as the wheels can slip in the steepest areas. This is kind of like trying to run up a hill of sand on a beach. With every step forward, you slip a little way back down the hill. Driving through the Mount Rainier quadrangle, there is a relatively obstacle-free path to reach the crater rim, which is now called Summerlin Trail. Perseverance is trekking to the next waypoint near an outcrop of rocks called Pico Turquino, where it will undertake its next science investigations with the Pixel and Sherlock instruments. So what are Pixel and Sherlock? Pixel, P-I-X-L, stands for Planetary Instrument for X-ray Lithochemistry. Pixel is an X-ray fluorescence spectrometer to determine the fine-scale elemental composition of Martian surface materials. Sherlock, S-H-E-R-L-O-C, stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. Sherlock is an ultraviolet Raman spectrometer that uses fine-scale imaging and an ultraviolet laser to determine fine-scale mineralogy and detect organic compounds. Mars weather at Gale Crater. We're going to talk about Sol 4341, which on planet Earth is October 22nd, 2024. Curiosity is taking daily weather measurements at Gale Crater in the southern hemisphere of Mars near the equator. At this location, it's currently late summer. On the Earth date of October 22nd, 2024, the high was 14 degrees Fahrenheit and the low was negative 71 degrees Fahrenheit. Mission overview for the Chang'e 4 lander and Yutu 2 rover. Yutu 2 is the robotic lunar rover component of CNSA's Chang'e 4 mission to the moon. It's launched on December 7th, 2018, and then made its first soft landing on the far side of the moon on January 3rd, 2019. Yutu 2 is currently operational. It's the longest lived lunar rover ever, now at over 2,000 Earth days on the moon. It eclipsed the previous lunar longevity record of 321 Earth days, which was previously held by the Soviet Union's Lunar-1 rover. Yutu 2 is the first lunar rover to have ever traversed the far side of the moon. The landing site is within the Von Karman crater, which is in the South Pole Aitken Basin on the far side of the moon, which was previously unexplored by landers. A recent update from this mission is that China's lunar rover sent home some of its latest images on the moon's far side. China's Yutu 2 rover has traveled over 1,613 meters on the mysterious far side of the moon as of Tuesday, and sent home the latest images that showed the lunar surface's diverse features. Today we're going to discuss a research paper that was published recently that combines data from the Chang'e 4 lander, the Yutu 2 rover, plus the American Lunar Reconnaissance Orbiter. And it has to do with lunar temperatures. I'm going to have some selected quotes from the paper entitled Analysis of Thermal and Dielectric Loss Features of Lunar Regolith Considering Real-Time Effect Solar Irradiance. The combination of solar irradiance and temperature data sets detected by orbiters can help explain the temperature variation and thermophysical properties of shallow lunar surface. This study develops a real-time effect solar radiance (ESI) model that takes into account the influence of lunar topography and integrates it with a thermal model to simulate physical temperature variations within the von Karman crater. We then simulated the temperature data in the 4 frequencies consistent with the Chang'e 4 microwave radiometer and obtained the average ranges of dielectric loss. These findings provide valuable insights for analyzing lunar surface temperature and observed brightness temperature, as well as for inverting physical and dielectric properties of the shallow regolith, for example, dielectric loss. The lunar surface temperature, LST, and the thermal properties of lunar regolith are significantly affected by solar radiance, the primary heat source on the moon's surface. Effect solar irradiance, ESI, received at the lunar surface is not only crucial for providing reliable data on sunlight duration and intensity, which is vital for selecting optimal landing sites for in situ scientific exploration, but also plays a key role in deciphering the thermal behavior of the regolith observed by orbiters and in constraining the physical and thermal properties of the shallow regolith. ESI on the lunar surface has been the subject of study for decades, particularly in the permanently shadowed regions of the lunar poles, which are of interest in the search for water ice. However, it is important to note that the surface and shallow temperatures detected by orbiters represent brightness temperatures, which should not be directly equated with physical temperatures. Although the Lunar Reconnaissance Orbiter Diviner Band 7 provides a reasonable approximation of the LST, and again, LST stands for lunar surface temperature. So here's my summary of why this is important for us to consider. LRO has been collecting data on the reflected light from the moon for around 15 years. These scientists have compared this on-orbit data with the Chang'e 4 landers data from the lunar surface. This validates the data from LRO. One of LRO's specific instruments provides a good temperature reading for the moon's surface. Then this data can then be used to plan where to build sites and where to prospect for water ice. This is the reason why this paper is of interest. If you're going to build bases on the moon, if you're going to explore the moon, understanding what the temperature variation can be normally would be great. The moon has no atmosphere, therefore the temperature variations during a lunar day or a lunar night correspond to the solar radiation that it has at the time. Now it's time for Martian sightings. In this segment, we're going to cover sightings of aliens, unidentified flying objects, and unidentified anomalous phenomenon, also known as UAPs. This week, there were no confirmed sightings of outer space aliens, Martians, UFOs, or UAPs. For the solar activity report, the sunspot regions, there's about 9 of them, very low magnitude. They appear to be very benign, so the sunspot regions are listed there on the graphic. And then the solar activity in the past few hours back when this data was gathered, you can see that very low levels of solar activity. So the solar activity appears to be pretty quiet. And that's your solar activity report for today. And now we go to the music segment. We always want to include some of the excellent space music that's being generated. So a fabulous song from 2034 by Spectral Valkyrie, Overman. Enjoy. So this segment is about robot development. And in this particular point, I'm not going to try to predict when robots are going to have sufficient manual dexterity or be able to perambulate well enough to do all human jobs. The point is just to keep an eye on the updates and developments as many new robots are introduced into the workforce. So the first one I'm going to play is snippets from the introduction of the Figure 02 robot, and it'll be without a whole lot of comment from me. Look at the hand motion, the implied dexterity, the ambulation as it walks, and realize that although this is an early point in its development, I don't think it's going to be too long before this is able to do a number of different jobs. Please keep in mind that this company was founded less than 2 years ago. Look at the Event Horizon Indicator Update on the grind towards the economic singularity. The economic singularity is an event in which humans lose their jobs to cognitive automation. Cognitive automation includes both bots and AI. I've devised an indicator equation that tracks a simple set of economic facts collected by the US Federal Reserve and published each month. As this indicator moves closer to zero, we're getting closer to what I consider the economic singularity. I created this equation and graph because the discussion on the replacement of human labor by AI and bots has been too nebulous and vague. This provides concrete measurement of directionality. I'm going to indicate it in two ways, a symbol and a graph. The symbol is an ellipse in which the point at which you get to totality, when the dead moon completely blots out the vibrant sun. This total eclipse indicates a completed economic singularity. As you can see in the symbol, right now the sun, representing the human labor force, is not shadowed by the moon, which represents the onrushing advent of human-level intelligence in computer software, or in human-level dexterity in robotics. Now the graph that's shown here combines two factors. One is the US male participation rate. The second is the US unemployment rate. You can see over the decades this indicator has dropped consistently. You can also see that during the complete shutdown of the US economy for the COVID pandemic, that this indicator briefly crossed the zero line. Therefore, it's important to point out that the indicator must remain below or at zero for an extended period of time. We're attempting to measure permanent technological unemployment. This is a secular change, not a cyclical moment in time. Summary: today the economic singularity has not been reached. Not yet. Omni, futurist,